Let's suppose we want to compare two means between different populations. So in this scenario, we have a group of students who have had math activities, extra math activities given to them, and then our other group is no extra activities have been given to them. So otherwise, we're assuming everything else is the same between these two groups. In the group with math activities, there are 47 students. Without, there are 38. These two numbers do not need to be the same. Then we have the X bar, so the sample mean recorded value, and the S, the sample standard deviation recorded value among those students. So what we're hoping to do here is find a 90% confidence interval for the difference in average test scores. Really what we're saying here, to be more specific, the difference in average test scores between students who had extra activities and those who did not. So what we're hoping to find is some prediction for what mu1 minus mu2 is, which here's, let's call this population 1 and let's call this population 2. So we're hoping to find a confidence interval for the true average for those with activities minus the true average for those without. So we're going to kind of walk through, instead of going by hand, we're going to think about which function in our calculator would we use. So there are two pieces in particular we want to look at. First of all, we have two distinct populations. So we're going to be looking at a two-sample interval. And then from there, the question is, okay, well, is it a two-sample Z interval or T interval? We know that with means, sometimes we use Z, sometimes we use T. That distinction comes down to, well, do I know the sample standard deviation S or the population standard deviation sigma? Here we know S, right? If we're using the sample, that's going to be a less exact result. So we're going to use the curve that allows for a little bit more uncertainty here, right? Or it accounts for that. So we're going to use a two-sample T interval. So if we go to, right, stats, test, two-sample T interval, and that's kind of your path on your TI-83 or TI-84 calculators. But you get to this two-sample T interval. The other part is there is a two-sample T test. We know we want an interval because we're specifically asked for a confidence interval. So the various inputs it's looking for, almost all of them are here in the table, right? So if this is population 1, that means here's N1, here's X bar 1, here's S1, and then same thing for here, except these are going to be N2, X bar 2, and S2. So you can put all of those in. Now, be careful about the order, because the order that the table gives it will not necessarily be the order that the two-sample T interval asks for that information. So for example, if you were to go to that two-sample T interval, the first thing it asks for is X bar 1, right? So we're not going to put in 47, we're going to put in 71.4. The next thing it asks for is SX1. Okay, well, again, this notation's not great, but it's close. We kind of know what we're looking for, so that's 4.5. And then N1, which was first in our table, but is last in our actual function here, two-sample T interval, that's going to be 47. We do the same thing for X2. We're just going to put in the right pieces where they need to go. So I'll kind of skip that part, but if you scroll down a little bit, it's going to ask for, right, a C level, or confidence level. Remember that this percentage that we put in there, we want to put it in as a decimal. So we're going to say 0.90 or just 0.9. That's fine. And then the very last thing, it's going to say, well, do you want this to be pooled? Unless you have some reason to believe that these two standard deviations should act like each other, the true standard deviations, we're going to say no. So we're going to say no, we do not want these pooled. So in general, that'll be the case, and then we can calculate this. If we do, we're going to come up with an interval of 1.5 1034 as our lower bound, 5.2966 as our upper bound, right? So this is the lower, this is the upper. Keep in mind there are some other outputs that this gives you. So this is using, the calculator function will use a calculated degrees of freedom. That's a little bit different from the conservative degrees of freedom that we've talked about in the notes. So just keep in mind, if you're doing this by hand instead of with the calculator, you might get slightly different values than this, but they should be fairly close, especially because we have reasonably large sample sizes here. So otherwise, it'll summarize the rest of the data for us. And that's pretty much it for our 90% confidence interval.